Plankton are tremendously important. From the Greek for wanderer, they serve as the base of the marine food web. When we eat fish, we are ultimately eating plankton. How plankton respond to a warming world will largely determine our future, along with the future of all life on Earth. After all, as I have pointed out repeatedly in this space, life on Earth began in the global ocean. As the global ocean goes, so goes life on Earth. As I have indicated via a short video at GuyMcPherson.com, some populations of plankton have declined 40% since 1950, and plankton are on the verge of disappearing completely. This latter conclusion is based on a peer-reviewed open-access paper published January 22, 2014 in Global Biogeochemical Cycles. I referenced this paper more than a decade ago. Finally, other scientists are realizing the importance of plankton in a global ocean that is warming and acidifying. From Yale Environment 360 comes an article titled, "Researchers Parse the Future of Plankton in an Ever Warmer World." Published on October 14, 2024, the subhead indicates the importance of oceanic warming and acidification. Quote, "Plankton form the base of the world's food chain, but warmer and more acidic oceans are affecting their numbers and variety. Some species, which make for good fish food and carbon storage, are largely declining, while others are shifting their ranges and blooming times." End quote. Here's the lead. Quote, "Across the world's oceans, an invisible army of tiny organisms has a supersized impact on the planet." End quote. The remainder of the first paragraph continues with an important explanation. Quote, "Plankton are at the base of the ocean food chain, feeding fish that feed billions of people. They are responsible for half of the world's oxygen supply and half our planet's annual carbon sink. Minuscule but powerful, their presence can help or hinder ecosystems by soaking up greenhouse gas, for example, or by spewing toxins. Where plankton live, how many there are, and when the bloom and which species dominate each play a huge role in this delicate balance, and our changing climate is spurring a sea change in all of it." End quote. A marine biologist at the University of Southern California has charted plankton's future. In the article at Yale Environment 360, he is quoted, quote, "We're headed into an ocean and, for that matter, a world that we're not going to recognize because it's changing so fundamentally." End quote. The third paragraph of the article at Yale Environment 360 tells a shocking story as it attempts to catch up with the peer-reviewed literature I have been citing for more than a decade. Quote, "Climate change is hitting our oceans hard, making them warmer and more acidic while radically altering currents. The outlook for plankton is mixed. Some studies report overall plankton numbers dropping, while others show them rising in some major ocean basins." End quote. In other words, there is variation in plankton abundance among locations. One expert quoted in the article at Yale Environment 360 said, quote, "I always find it surprising how little is known about plankton." End quote. The subhead in the Yale Environment 360 article mentions plankton blooms. A detailed explanation comes about a third of the way into the article. Quote, "Pollution from both the burning of fossil fuels and from wildfires can carry nutrients far out into ocean waters. The wildly destructive Australian wildfire season of 2019 to 2020, for example, poured so much nutritional iron into the water that phytoplankton concentrations doubled between New Zealand and South America, creating an algae bloom bigger than Australia that lasted for months. The biggest surprise was how long the blooms lasted. The amount of carbon soaked up by those organisms is thought to have roughly matched the carbon spewed by the fires, a helpful factor in the context of climate change." End quote. Unfortunately, such blooms don't make a big dent in the big picture fight against global warming. After all, we have collectively burned thousands of years of deposits of oil and gas. As pointed out by the marine biologist at the University of Southern California I mentioned earlier, quote, "The phytoplankton blooms aren't going to be able to cut it." End quote. The article in Yale Environment 360 mentions the potential for dumping massive quantities of iron into the ocean as a means of fertilization. The iron would encourage plankton to soak up carbon dioxide. However, the consequences of this approach remain unknown. In addition, There have been international moratoria against large-scale commercial fertilization efforts since 2008. Violating international law has never stopped the so-called leaders in the country of my birth. I suspect it won't help this time either. The bottom line comes from the marine biologist at the University of Southern California who charted the future of plankton. Despite abundant evidence to the contrary, he said, quote, "I don't think we're going to drive ocean life to extinction, but there's going to be a different dominant species, and maybe they're not going to be the ones we wish were there." End quote. Here we are amid a mass extinction event. We have known about this ongoing mass extinction event since it was reported by E.O. Wilson in his 1992 book, The Diversity of Life. We have known it is the fastest event in planetary history since the Design to Fail Intergovernmental Panel on Climate Change issued its global warming of 1.5 degrees on October 8, 2018. Yet, the marine biologist at the University of Southern California who charted the future of plankton said, quote, "I don't think we're going to drive ocean life to extinction." End quote. Wishful thinking aside, I think we are already driving marine life to extinction. The ongoing mass extinction event is not giving marine life a pass.